In our last study that we made available on arXiv, we defined a new concept in material science, engineering material neural networks. Basically, when we want to create motion out of a part today, we rely extensively on electronics, which are expensive and energy consuming. Our idea is to develop engineering material neural networks to limit this dependency on expensive electronics. In order to do this, we use a computation inside the matter by having the structure computing the optimal output for the structures in a service. In order to do this, we create a grid-like structures of material which are connected with material connectors. And this is a grid-like structures is needed in order to be able to serve as a function approximator as a normal neural network would do. The material properties of the structures here are represented by lambda and could be updated in service to find the best value in order to link the input phi I to the output phi O in the function that we want to approximate. We develop in the study different potential way of training the system, which are classified here in dependence on the amount of digital computation needed in order to achieve the type of structures and the amount of parameters that could be adapted during the training. We also highlighted different directions of research in order to be able to achieve engineering material neural network. This includes, for instance, to try to develop Hebbian learning for other type of system, try to replace the manual update of material properties by automatic update, and working on the junction and the connection between different materials. We've developed this kind of concept for different systems, such as related to stiffness, actuation, thermal and electrical conductivity, magnetic field, and opacity. And we propose these structures and potential application for that type of structures. So to summarize, we have a new concept, engineering material neural network, which has been created by being influenced by neural network, engineering materials, and material adaptation. We propose different examples of future research directions. And one of these research directions is to optimize different materials that could be used in a type of structures. We highlighted three of them: engineering living materials, which could use micro living organisms in order to control the material properties of the material, and the composite materials, because in order to have a forward function of the materials, you also need to be able to update the properties of the material, and therefore different phases are needed in order to achieve this. And similar with macrostructure materials, you have different scale, and this scale could have different functions, such as doing the feed forward of the engineering material neural network or updating the properties of the system. Thank you very much. This is a paper that is available in arXiv if you are interested in this concept.